3 different AI systems. One simple question. What was the title of this researcher's doctoral thesis? All 3 gave a specific, confident, professional-sounding answer. None of them was right, and not one of them said I'm not sure. The wrong answer is not the interesting part. Software gets things wrong. The confidence is the interesting part, and there is now a good explanation for it. 3 things tonight. Why it invents, why it can't learn its way out, and why it almost never admits that it doesn't know. Every number here was measured on this machine today, or comes from a named source. We call this hallucination. That word suggests a malfunction, a system glitching. It's the wrong picture. Nothing malfunctioned. The system did exactly what it was built and graded to do. Start with what these systems actually optimize for. Here is a machine that knows nothing at all. No facts, no world model, no idea what a single word means. It reads text and records one thing. Which word tends to follow which 2 words? I fed it 10,000 real research paper titles, pulled from AR14 this morning. Then I asked it to write some new ones. Here are 4 of them. They look like real papers. The rhythm is right. The vocabulary is right. If you work in this field, at least one of them probably sounds familiar. None of them exist. 85% of what it produced appears nowhere in those 10,000 titles. It didn't copy them. It invented them. And notice, this thing cannot lie to you, because it has no idea what is true. It also can't be right on purpose, for exactly the same reason. Fluent and false are not opposites. They are independent. A real language model is enormously more sophisticated than 9 lines of counting. But what it is trained to do has the same shape. Given everything so far, what plausibly comes next? Nowhere in that objective does the word true appear. Which raises the obvious objection. Fine, but it read the whole internet. Why doesn't it just know? Because facts are not all the same shape. Spelling has a pattern. Grammar has a pattern. See enough examples, and you derive the rule. A person's birthday has no rule. Neither does who wrote which paper. Call those arbitrary facts. There is nothing to generalize from. You either met it, or you cannot derive it. So the real question is how much of what's out there did the model see only once? So I counted, on that same corpus, 10,000 papers, 46,000 individual authorship facts, 36,000 different researchers. 30,000 of those facts are the only time that person appears anywhere in the corpus. 66%, 2/3 of everything there is to learn here, you would see exactly once. This quantity has a name and a long history. The singleton rate. It comes from work on estimating how much of a distribution your sample hasn't shown you yet, credited to Alan Turing and published by I.J. Good in 1953. And here is the result that ties it together. A 2025 paper from OpenAI and Georgia Tech shows the error rate on this kind of fact is at least the singleton rate. Not a tendency, a floor. The natural response is, so train on more. I measured that too. Same corpus, sampled at 4 sizes. 500 papers, 93%. 1,500, 87. 4,000, 77. 10,000, 66. 20 times the data, and it fell from 93 to 66. It is going down. It is not going down fast. And it has to reach 0 before guessing stops being the model's best option. The reason is simple. A bigger corpus doesn't only tell you more about the same people. It brings new people with it. The long tail doesn't shrink. It moves. Honesty check, same as every episode. This is 10,000 papers from one fast-growing field. It is not anybody's pre-training corpus, and 66% is not any real model's hallucination rate. A frontier lab trains on vastly more, and their number would be much lower. The shape of the curve is the point, not the height. Which brings us to the part 1 found genuinely surprising. Suppose the model does have some sense that it is unsure. Why doesn't it say so? Because saying so scores worse. And that turns out to be measurable, not metaphorical. Here is how nearly every AI benchmark is scored. A correct answer, 1 point. A wrong answer, nothing. And I don't know, also nothing. scored identically to being wrong. That paper surveyed the 10 evaluations that dominate the major leaderboards. 9 of them give no credit at all for admitting uncertainty. GPQA, MLU Pro, SWE Bench, Humanities Last Exam. The benchmarks every model launch is measured on. So I ran that exam. 1,000 questions. 2 students with identical knowledge. Both genuinely know 600 answers. On the other 400, both are equally lost, and there are 4 options. The only difference is what they do when they don't know. The honest student scores 600. The guesser scores 700. 100 points higher, 16%, on leaderboards where models are separated by 2. And on the way there, the guesser stated 300 confident falsehoods. The honest one stated none. The benchmark ranks the bluffer first. Same knowledge, same ability. One difference: willingness to bluff. Now run that incentive across every benchmark and every model release for years. You don't get a system that lies. You get one that always answers. That is what we selected for. The authors put it well. Language models are always in test-taking mode. One more, and it reaches back to the first video on this channel. Ask a model how many D's are in the word DEEPSEEK. In that paper, one model answered 2 or 3 across 10 separate tries. Others said 6 and 7. There's one. The first video on this channel explained why that question is hard. The model never sees letters. It sees for chunks. But look at what it does with a question it cannot answer. It answers anyway. So what actually helps? 1. Give it the source, so the fact is in front of it instead of buried in its weights. Retrieval and search genuinely reduce this. The paper is careful to point out they don't remove the incentive to guess when the search comes back empty. 2. And this is the paper's actual proposal. Put the grading rule inside the question. Answer only if you are more than 75% confident. A wrong answer costs 2 points. I don't know costs nothing. Now abstaining is sometimes the highest scoring move available. That is not a new model. It is a new mark scheme. Would that end hallucination? Probably not entirely, and I'll flag that as an open question rather than a finding. There are arguments that some rate of this is unavoidable for any system that generalizes beyond its data. That debate is not settled. So, it isn't lying to you. Lying requires knowing the truth and choosing to leave it. There is nothing in there doing that. It's a system that was scored on answering, and it learned the lesson every student learns. A blank is worth nothing. Fill something in. Next time it invents something with total confidence, that isn't a glitch. It's the mark scheme showing through.